23rd of June, 1942. Inside Montreal Locomotive Works, drafting tables held blueprints of a gun mount that would never see its parent tank enter combat. Outside, newspapers carried headlines from North Africa, where British gunners struggled to keep pace with their own armor. A staff officer in Cairo had calculated the problem in hours and miles. Towed 25-pounders required 4 hours to displace and resight, while tank squadrons advanced 20 miles ahead in half that time. The solution arrived not from Birmingham or Detroit, but from Canadian engineers who saw opportunity in a rejected tank chassis. They mounted Britain's standard field gun on tracks, creating a weapon that would fire its first rounds at Normandy's beaches and its last in the heart of Germany. The Sexton self-propelled gun answered a question the Desert War had made urgent: how to marry artillery's reach with armor's speed. The problem crystallized in the Western Desert during October and November of 1942. Staff officers at 8th Army Headquarters in Egypt reviewed after-action reports with mounting concern. Gun line displacement times, measured in hours, created gaps in fire support that German commanders exploited ruthlessly. British armor routinely outran towed 25-pounders by double-digit miles, leaving tank regiments advancing without their artillery shield. The mathematics were brutal. A towed battery needed 4 hours to limber up, move, and lay in a new position, while tracked formations moved continuously. The United States provided a stopgap. The M7 Priest, mounting a 105mm howitzer on a Sherman chassis, entered British service in late 1942. The Priest solved mobility immediately. Tracked self-propelled guns could keep pace with armored divisions, firing from positions mere kilometers behind the forward edge. But the solution carried a hidden cost. The Priest's 105mm ammunition did not match British scales. Every shell required separate importation from American stocks. British logistics, built around the 87.6mm family of the 25-pounder, faced chronic supply penalties. Ammunition trains ran 2 calibers. Forward dumps stocked 2 types of rounds. The War Office calculated the inefficiency and issued a directive: develop a tracked mount for the standard 25-pounder field gun, not a new howitzer. Mobility could not come at the price of logistics chaos. The 25-pounder had anchored Commonwealth artillery since the late 1930s. Its 87.6mm shell delivered reliable high-explosive, smoke and illumination rounds to 12,250 meters. More critically, the shell's production tooling spread across Britain, Canada, Australia, and India. Changing to a new caliber meant retooling factories on 4 continents. The solution, British planners concluded, must preserve the ammunition chain while adding tracks. The directive went to Montreal, not to Michigan. Montreal Locomotive Works received the contract in early 1942. The company already produced Ram tanks under Canadian Department of Munitions and Supply orders. The Ram, based on American M3 medium tank automotive components, never fought as a gun tank. This hull, however, proved ideal for conversion. Engineers removed the turret and opened the fighting compartment. They mounted a QF 25-pounder Mark II in a limited traverse mount at the front of an open-topped superstructure. The gun sat high enough for full elevation, allowing standard indirect fire missions. Crew positions accommodated 6 men: commander, driver, gunner, 2 loaders, and a radio operator. Onboard stowage held 105 rounds of 25-pounder ammunition. The prototype rolled off the line on 23 June 1942. Trials began immediately at Canadian ranges, then continued in the United Kingdom through mid-1943. The vehicle weighed approximately 25 long tons. Top speed reached 25 miles per hour, with operational range around 200 kilometers on a full tank. The tracks, identical to Sherman components, simplified maintenance. British evaluators noted the gun's stability during firing and the crew's ability to service the weapon under armor protection from overhead shell fragments. The Ministry of Supply accepted the design in May 1943 and christened it Sexton, following British practice of naming self-propelled guns after ecclesiastical terms. Montreal Locomotive Works shifted to production. The first variant, Sexton Mark I, used the Ram chassis. When Ram production ended, engineers adapted the design to the Grizzly, Canada's version of the Sherman, creating the Sexton Mark II. The automotive components remained interchangeable with standard Sherman parts, easing field maintenance across Commonwealth armored divisions. Between 1943 and 1945, Montreal Locomotive Works built approximately 2,150 Sextons. The production rate peaked in 1944, when vehicles flowed directly to British and Canadian field regiments preparing for Northwest Europe operations. The Sexton preserved the British ammunition system while delivering the mobility Commonwealth divisions needed. A standard shell family on a track chassis gave gunners the ability to follow armor without retooling ammunition production. By late 1943, the first Sextons entered service in Italy. By spring 1944, they equipped regiments training in England for the cross-channel invasion. Late 1943 through May 1944 found Sextons moving from Canadian factories to British assembly areas. Convoys departed Halifax carrying vehicles sealed in protective cosmoline. They docked at Liverpool, where Royal Army Service Corps drivers took delivery. The vehicles moved to artillery depots across the British Isles for distribution to field regiments. The re-equipping process began months before D-Day. Units surrendered their towed 25-pounders and limbers, trained on the self-propelled mounts, and integrated the Sextons into division fire plans. The 147th Field Regiment Royal Artillery, known as Essex Yeomanry, converted to Sextons in early 1944. Canadian units followed. The 23rd Field Regiment, self-propelled, Royal Canadian Artillery, received its Sextons before commitment to Northwest Europe. Training emphasized the vehicle's capabilities and limitations. Setup time collapsed from hours to minutes. Crews practiced occupation of hasty firing positions, rapid-fire missions, and displacement under simulated counter-battery fire. Training data documented dramatic improvements. First-round times dropped from the extended sequences required by towed guns to single-digit minutes from halt to shot. The integration required more than gunnery practice. Wireless number 19 sets networked each Sexton to battery and regimental fire direction centers. Forward observation officers in tanks or carriers called targets using standard grid procedures. Fire direction centers computed data using slide rules, plotting boards, and meteorological corrections. The Sexton's radio fit allowed it to receive fire orders while moving, reducing the interval between call for fire and impact. Crews trained to fire from open-topped positions, a departure from towed gun drill but necessary for the vehicle's configuration. The ammunition remained constant. Every round fired by a Sexton matched rounds fired by towed 25-pounders across the theater. Regimental ammunition trucks carried identical stocks. Forward dumps required no separate allocation. Logistics officers calculated tonnages based on tube count, not gun type. This interchangeability proved critical during sustained operations, when divisions mixed towed and self-propelled regiments based on mission requirements. A towed regiment could draw ammunition from Sexton stocks without conversion tables or special requisitions. By May 1944, Royal Artillery and Royal Canadian Artillery orders of battle included multiple Sexton-equipped regiments. Some Canadian units still carried M7 priests from earlier allocations, but British policy prioritized Sexton distribution to maintain ammunition commonality. On D-Day, forward fire support units would include both types. Sexton-equipped regiments would enter Normandy in strength by late June and early July, expanding the self-propelled gun base behind British and Canadian armored divisions. The vehicle had moved from Montreal drawing boards to the invasion order of battle in less than 2 years. 6 June 1944, Juno Sector, Normandy coast. Self-propelled artillery fired from landing craft en route to the beaches. Canadian artillery regiments, some equipped with M7 priests, engaged German positions from LCTs before disembarkation. The practice, rehearsed during training, delivered suppressive fire during the critical minutes of beach approach. Once ashore, self-propelled guns displaced inland with the armor, establishing gun lines within range of advancing infantry. Sexton-equipped units entered the bridgehead through June and into July. The 23rd Field Regiment, self-propelled, Royal Canadian Artillery, arrived on 26 July and joined the breakout battles south of Cannes. The Essex Yeomanry, with Sextons already ashore, supported British armor during Operation Epsom and subsequent actions around Cannes. German defensive doctrine assumed Allied artillery would be road-bound and slow to reposition. Sexton batteries contradicted that assumption. Gun lines leapfrogged, maintaining positions within a few kilometers of supported armor. When German counter-battery fire ranged in, Sexton batteries displaced in minutes rather than hours, denying German gunners stationary targets. The tactical advantage appeared in response times. Forward observers called targets from hull-down positions or from church steeples in captured villages. Fire direction centers computed firing data and relayed it via wireless. Sexton crews loaded, laid, and fired within minutes of receiving the order. The track chassis allowed occupation of unprepared positions: fields, orchards, farmyards. Towed guns required surveyed sites with cleared trails for limber access. Sextons simply drove into firing position, halted, and began engagement. Displacement took even less time. At the order, crews secured ammunition, commanders checked maps, and the battery rolled to the next position. By late July, Sexton batteries fired alongside the priest-equipped units that had landed on D-Day. Both types delivered fire missions, but logistics favored the Sexton. Every 25-pounder round in theater fit the Sexton's breech. Priests required dedicated 105mm stocks. As operations intensified and ammunition consumption soared, the unified shell supply for Sextons and towed 25-pounders simplified forward resupply. Trucks carried one caliber. Dumps stocked one type. Divisional artillery commanders planned fires without worrying whether Sexton or priest units would execute the mission. The British shell family, married to tracks, proved its operational value in the close terrain of the Normandy bocage. German formations found themselves under continuous indirect fire from guns that moved faster than German counter-battery cycles allowed. The tracked 25-pounder, conceived in the desert, fought its first sustained campaign in Norman hedgerows. July 1944, Sector. Inside a camouflaged command post, a fire direction center processed target grids relayed by forward observation officers. Wireless number 19 nets carried calls from tank commanders and infantry officers in forward positions. A sergeant updated the plotting board with reported enemy strongpoints. Another computed deflection and elevation using slide rules, meteorological data, and range tables. The process, refined over years of artillery science, reduced ballistics to simple arithmetic. Distance to target, muzzle velocity, propellant temperature, wind speed, bearing. Corrections went to battery positions via radio. Guns fired, adjusted based on observed fall of shot, and fired again for effect. Sexton batteries executed this cycle while mobile. The gun line could receive a fire mission, halt in a field, lay the guns, fire the mission, and displace to a new position in under 10 minutes. German counter-battery doctrine assumed pauses. Time to unlimber, time to survey, time to lay and load. Sexton gun lines eliminated those pauses. Training and equipment combined to create a fire support system that matched the tempo of armored warfare. When British and Canadian tank regiments pushed through gaps in German lines, Sexton batteries followed within supporting range, ready to fire on call. The system's scale appeared during Operation Goodwood, 18th through 20th July 1944. British planners allocated 760 guns for the offensive east of Caen. Ammunition trains delivered approximately 297,600 rounds to forward dumps. The concentration included field artillery, medium guns, and heavy pieces. Sextons formed part of the field artillery component, alongside towed 25-pounders. The fire plan synchronized across Army Group Royal Artillery and Corps-level batteries. As British armor crossed the Orne River bridges, tube artillery delivered suppressive fires on German positions beyond Caen's eastern suburbs. The intensity of fire reflected logistical priorities. British ammunition consumption in Normandy surpassed daily allocations. 25-pounder and 5.5-inch gun ammunition requirements exceeded initial planning estimates. Supply officers shifted priority from petrol oil lubricants to ammunition lift. Trucks ran constant shuttles from beach dumps to forward gun parks. The availability of shells, not fuel, determined fire mission tempo. Sexton batteries, sharing ammunition with towed regiments, drew from the same forward stocks, simplifying resupply during rapid displacement phases. The network of fire direction, wireless communication, and mobile gun platforms created a mathematical weapon. Individual guns delivered single rounds. Networked batteries delivered concentrations that saturated target areas. Observers calculated effects not by single impacts but by coverage. So many rounds per 100 square meters over so many seconds. The Sexton's contribution lay in maintaining that network's tempo. Towed guns could mass fires but needed time to move. Sextons massed fires and moved with the armor. Ammunition priority became the enabling weapon, and supply drove operational tempo. July 1944, Chantilly Sector. German SDKF Z-124 Wesp self-propelled howitzers occupied tree-lean positions facing Commonwealth lines. The Wesp mounted a 105mm Lu FH-18 howitzer on a Panzer II chassis. Crew of 5. Maximum range approximately 10,500 meters. Onboard stowage 40 rounds. The vehicle represented German attempts to match Allied artillery mobility, marrying field guns to tracks using available chassis. Wesp batteries supported Panzer and Panzergrenadier divisions, providing mobile fire support comparable to Allied self-propelled artillery. The comparison revealed asymmetries. German production of Wesp totaled approximately 676 vehicles between 1943 and 1944. Montreal Locomotive Works alone produced over 2,000 Sextons. British and Canadian field regiments in Northwest Europe included multiple Sexton-equipped units, Essex Yeomanry, Canadian 23rd Field Regiment, among others. The numerical disparity extended beyond vehicle counts to ammunition stocks and replacement capacity. Commonwealth logistics sustained high rates of fire and absorbed vehicle losses through continuous factory output. German logistics, strained by strategic bombing and fuel shortages, rationed ammunition and struggled to replace battlefield losses. Range differences mattered tactically. The Sexton's 25-pounder reached 12,250 meters, extending coverage beyond the Wesp's maximum effective range. German self-propelled gun batteries operated within a shorter engagement envelope, accepting counter-battery risk to deliver fires on Allied positions. Commonwealth forward observers, often positioned in tanks or armored carriers, could call Sexton fires from positions beyond Wesp range, forcing German guns to displace or accept suppression without effective reply. Mobility parity could not offset mass. German SP artillery possessed the same tracked cross-country capability as Sextons. Wesp batteries could displace rapidly, occupy unprepared positions, and fire on the move's halt. But German armored divisions fielded far fewer self-propelled guns per division than Commonwealth formations. A typical German armored division in Normandy might field 1 battalion of mixed-towed and self-propelled artillery. A British armored division's artillery component included multiple field regiments, several equipped with Sextons, backed by medium and heavy regiments with towed guns. When fire missions overlapped, the weight of available tubes determined outcome. By midsummer 1944, Sextons outnumbered German self-propelled howitzers several to 1 in main Allied thrust sectors. German artillery officers noted the disparity in post-battle reports. Allied artillery appeared inexhaustible, firing concentrations that German logistics could not sustain or match. The Wesp, technically capable, fought under constraints its designers never anticipated. Lack of ammunition, lack of fuel, and lack of replacement vehicles reduced German mobile artillery to defensive economy of force missions. Sexton batteries, supplied by an intact transatlantic industrial base, fired offensively at planning rates that assumed ample stocks. The tracked guns faced each other across the Normandy front, but only one side possessed the industrial depth to sustain the match. July through August 1944, 21st Army Group rear areas and forward gun parks. Night convoys of Canadian military pattern trucks hauled 25-pounder shells from beach dumps to forward ammunition points. Each truck carried palletized loads, high explosive, smoke, illumination rounds stacked by fuse type and propellant charge. At first light, gun crews drew basic loads, replenishing onboard stowage expended during previous days' fire missions. The cycle repeated daily. Ammunition availability determined whether fire missions received approval. Forward observers learned to phrase requests in terms of rounds available, not rounds desired. Critics of tracked self-propelled guns predicted fuel and maintenance strain. Sextons consumed more petrol than towed guns, which burned fuel only when horse-drawn or truck-towed between positions. Maintenance requirements for tracks, engines, and transmissions exceeded the simple upkeep of towed carriages. British logistics planners, however, accepted the trade. Operational analysis showed that ammunition, not fuel, limited fire support operations. A Sexton battery could operate for days on a single refueling if ammunition stocks remained adequate. Conversely, ample fuel meant nothing if shell dumps ran dry. The pursuit phase after the Normandy breakout tested logistics. As Commonwealth divisions advanced toward the Seine, Sexton batteries displaced dozens of kilometers daily, following tank columns across open country. Fuel consumption rose, but so did the distance from supply heads. Red Ball Express, the American truck convoy system, highlighted the challenge, delivering hundreds of tons of supplies daily to divisions advancing faster than logistics could follow. British and Canadian logistics mirrored the American effort, prioritizing ammunition and fuel over other classes of supply. Records from divisional logistics cells documented daily requirements in hundreds of tons. A single armored division consumed fuel, ammunition, rations, and spare parts at rates that required constant truck traffic. Sextons added to the fuel demand but reduced displacement time, allowing divisions to maintain continuous pressure on retreating German formations. The trade proved operationally sound. German forces, hobbled by fuel shortages and air interdiction, could not match Allied mobility even when terrain and dispositions favored defense. Sexton reliability contributed to availability rates. The Sherman-derived automotive components benefited from extensive field maintenance experience. Mechanics familiar with Sherman tanks adapted easily to Sexton repair procedures. Track replacement, engine service, and transmission overhaul followed identical protocols. When breakdowns occurred, repair echelons drew spare parts from Sherman stocks, avoiding separate supply chains. Operational readiness rates remained high through sustained operations, keeping gun batteries at strength during critical phases. By February 1945, 1st Canadian Army's Operation Veritable would pre-stock over 2.5 million 25-pounder rounds for the assault into the Rhineland. The figure represented planning that assumed high expenditure rates and mobile operations. Sextons, backed by that massive ammunition and sustained by reliable logistics, embodied a system where mobility and firepower combined not through technical innovation alone but through industrial and logistical capacity. The gun's success lay as much in the supply echelon as in the firing battery. 7th through 16th August 1944, south of Caen, Verrières Ridge to the Falaise Road. Operation Totalize and Operation Tractable combined armor, mechanized infantry, and continuous artillery into night offensives aimed at encircling German forces in the Falaise pocket. Canadian planners integrated all available fire support into timed barrages that marked advance routes and suppressed German defensive positions. Tracer from Bofors anti-aircraft guns marked lanes through darkness per detailed fire plans. Bombers struck German strongpoints in coordination with ground forces. Into this orchestration fit Sexton-equipped field regiments, their guns adding weight to rolling barrages that preceded advancing armor. 2nd Canadian Corps orders specified timed concentrations. Artillery fired on grids according to schedule, not observer calls, creating predicted fire that advanced in 100-meter increments as tanks and carriers moved forward. The technique required precise timing and navigation. Tank commanders matched their advance to artillery lifts, staying close behind the curtain of exploding shells. Sexton batteries fired from positions calculated to support the entire advance, displacing as necessary to maintain range. The innovation extended to infantry movement. Defrocked M7 Priest chassis, turrets removed and interiors converted to troop carriers, moved Canadian infantry under armor for the first time in Northwest Europe. These kangaroos, improvised from available vehicles, allowed infantry to keep pace with tanks during the assault phase. Sextons provided the fire shield for both arms. German defenses, expecting pauses between fire phases and assault waves, found themselves under continuous bombardment as mechanized columns pressed through prepared positions. Target-marking shells aided night navigation. Artillery fired colored smoke and illumination rounds to designate phase lines and direction markers. Observers used pre-registered targets, firing by map coordinates rather than visual observation, trusting survey data and meteorological corrections. The system worked because Commonwealth gunnery training emphasized mathematical precision. Guns laid by grid bearing, not by visible target. Crews fired by computed data, not by direct sighting. Sexton batteries executed these missions from positions kilometers behind the forward edge, their rounds impacting on German lines while their crews never saw the enemy. The method demanded coordination across multiple command levels. Brigade, divisional, and corps fire direction centers synchronized battery and regimental fire plans. Wireless nets carried timing updates and adjustment orders. When German counterattacks developed, observers shifted fires in real time, suppressing threats before they reached friendly positions. Sextons contributed to this network by maintaining mobility and ammunition supply. Batteries could fire prolonged missions, expending dozens of rounds per gun, then displace and resume fires after short intervals. The Falaise battles demonstrated mechanized fire support at operational scale. German defenders, skilled and determined, fought from prepared positions with veteran units and heavy weapons. Allied advances succeeded not through tactical surprise but through weight of fires and relentless pressure. Sextons participated in every phase: preparatory bombardments, rolling barrages, counter-battery missions, and harassing fires on withdrawal routes. The gun proved not a decisive weapon in itself but a critical component of a system that integrated mobility, firepower, and logistics into continuous offensive pressure. By mid-August, the same method, mechanized fire support synchronized with armor and mechanized infantry, would frame the Allied push to the Seine and beyond. 18th through 20th July 1944, east of Cannes. Operation Goodwood's fire plan enumerated 760 guns and approximately 300,000 rounds allocated for 3 days of offensive operations. Army Group Royal Artillery and Corps-level batteries synchronized with armored divisions preparing to cross the Orne River bridges. The concentration represented mass tube artillery at scales rarely achieved in Northwest Europe. Sextons formed part of the field artillery component, positioned to support the armored thrust with mobile fires. Allocation sheets detailed gun positions, target grids, and ammunition types. Forward observers received pre-planned fire missions timed to the armored advance. As British tank regiments crossed the Orne bridges in column, artillery fired suppressive concentrations on German positions covering the approaches. The initial bombardment lasted hours, saturating known German strongpoints with high explosive and smoke rounds. Medium and heavy guns engaged German artillery positions. Field guns, including Sextons, delivered direct support fires on infantry and anti-tank positions. German counter-battery doctrine assumed intervals between fire phases. British artillery practice exploited that assumption. Sexton gun lines displaced rapidly, occupying alternate positions prepared in advance. When German artillery ranged in on a previous position, Sexton batteries had already moved, maintaining short call-to-impact times even during displacement. The mobility prevented German counter-battery fires from achieving the suppression German doctrine required. Allied guns kept firing, and German guns faced targets that moved faster than counter-battery cycles allowed. British official histories record Goodwood as an immense concentration of resources aimed at a narrow breakthrough east of Cannes. The operation achieved limited territorial gains but demonstrated Allied capacity to mass firepower at chosen points. German defenders, despite prepared positions and experienced units, faced artillery fires that exceeded anything available to German commanders. The weight of tubes, volume of ammunition, and sustainability of fire missions reflected industrial capacity translated into operational capability. Sexton batteries contributed to that capability by remaining mobile and mission-ready throughout the operation. The method proven at Goodwood became standard practice in subsequent operations. Rolling barrages, timed fire plans, and rapid displacement entered routine orders. Artillery officers planned fires assuming mobility and ample ammunition. Forward observers expected responsive fires on short notice. The self-propelled gun had evolved from novelty to necessity, an expected component of armored division fire support. Sextons, by this point in the campaign, no longer required special mention in operational orders. They appeared in fire support annexes as standard equipment, their capabilities built into planning assumptions. Goodwood ended without achieving the breakout British planners desired. German defenses held, and British armor withdrew after 3 days of intense fighting. The operation's tactical results disappointed. Its operational impact lay in confirming Allied artillery superiority and the value of mobile fire support. German commanders noted the impossibility of matching Allied artillery concentrations. Post-battle reports described Allied fire superiority as overwhelming, a judgment that reflected not only the number of guns but their sustained availability and rapid repositioning capability. The Sexton, modest in individual capability, multiplied its effect through numbers and logistics. At Goodwood, that multiplication reached a scale German defenders could recognize but not counter. Late August through September 1944, Seine crossings to Channel ports and the Scheldt estuary. Sexton batteries crossed temporary bridges behind advancing armor, then occupied hasty firing positions and began missions within 20 minutes, a practice noted in Royal Artillery records during rapid movement phases. The pursuit after the Normandy breakout tested every aspect of mechanized warfare: logistics, navigation, maintenance, and fire support. German forces withdrew under continuous pressure, attempting to establish successive defensive lines while Allied divisions pursued. German artillery movement suffered constraints Allied guns avoided. Fuel scarcity limited German motorized columns. Allied air interdiction destroyed bridges, rail lines, and supply convoys, further restricting German mobility. Allied self-propelled regiments, by contrast, kept daily marches of tens of kilometers while remaining on call for fire missions. Sexton batteries occupied positions based on map reconnaissance, without pre-survey or registration fires, and delivered effective fires on first call. The system worked because crews trusted computed firing data and accepted the minor inaccuracies of hasty occupation. British logistics analyses emphasized petrol-oil lubricants limits for German forces versus Allied trucking capacity. German mechanized units frequently halted for lack of fuel, creating opportunities for Allied encirclement. Allied logistics, though stretched by the rapid advance, maintained minimum flow rates for fuel and ammunition. Sextons consumed fuel but delivered fires that hastened German withdrawals, creating operational effects that justified the logistical cost. The pursuit reached the Seine in late August. Advance guards secured crossing sites while engineers erected tactical bridges. Sextons crossed in column, displacing to positions covering the far bank. Fire missions during river crossings targeted German positions attempting to defend the water obstacle. Once across, Sexton batteries supported the advance toward Belgium and the Channel ports. The tempo barely slowed. Divisions moved, fought brief engagements, and moved again, covering distances in days that earlier campaigns measured in weeks. By September, Commonwealth forces approached the German frontier. The rapid advance ended as supply lines lengthened and German resistance stiffened. Sextons, which had fired from hastily occupied positions during the pursuit, now occupied surveyed gun lines for deliberate operations. The transition reflected operational realities. Pursuit required mobility and speed, but breakthrough of prepared defenses required precision and mass. Sextons adapted to both missions because their tracked mobility and standard ammunition allowed rapid shifts in employment. The pursuit phase, from Normandy breakout to the German frontier, covered hundreds of kilometers in weeks. Sexton batteries participated in every phase: breakout battles around Falaise, river crossings at the Seine, advance through open country toward Belgium, and reduction of German garrisons in bypassed ports. The vehicle's design, conceived in 1942 to solve a desert mobility problem, proved adaptable to the rapid warfare of summer 1944. The gun followed the armor, fired on call, and displaced without lengthy preparation. In doing so, it fulfilled the requirement British planners had articulated 2 years earlier: marry firepower to mobility without abandoning logistics. September 1944 through May 1945, from the Scheldt to the Rhine and into Germany. Sexton batteries fought through autumn mud, winter freeze, and spring thaw. Operations shifted from pursuit to deliberate assault. German resistance stiffened as Allied supply lines lengthened and German forces fell back toward their own logistical base. The campaign required sustained artillery support for infantry assaults, river crossings, and urban fighting. Sextons provided that support across terrain and weather that tested crew and machine. Operation Market Garden in September attempted to seize bridges across Dutch rivers. Supporting artillery included Sexton-equipped regiments firing missions to support airborne forces and ground columns. The operation failed to achieve its objectives, but Sexton batteries demonstrated their ability to deliver fires in support of complex, multi-axis operations. When British armor attempted to relieve airborne forces at Arnhem, Sextons provided covering fires despite extended ranges and uncertain target locations. The Scheldt campaign, October through November, cleared German forces from the approaches to Antwerp. Sextons supported assaults across flooded polders and fortified islands, firing missions that required precise targeting to avoid friendly forces in close proximity to German positions. The fighting took place in terrain unsuited to armor, yet Sextons operated effectively, their tracked mobility allowing occupation of positions among dikes and flooded fields where wheeled vehicles could not venture. Winter brought Operation Veritable, February 1945, First Canadian Army's assault into the Rhineland. Planners pre-stocked over 2.5 million 25-pounder rounds. The figure represented industrial capacity translated into tactical fires. Sexton batteries fired prolonged preparatory bombardments, expending thousands of rounds per battery over days of operations. German positions, fortified and defended by determined troops, absorbed fires that exceeded anything German logistics could deliver in reply. The Reichswald forest, flooded ground, and prepared defenses slowed but did not stop the advance. Artillery, including Sextons, provided the weight of fire necessary to suppress German positions and enable infantry assault. Rhine crossings in March required coordinated artillery fires at scales matching the Seine crossings months earlier. Sextons supported assault crossings, firing smoke and high-explosive missions to screen engineers and suppress German defenses. Once bridgeheads were established, Sexton batteries crossed and supported the exploitation into Germany. The final weeks of the war in Europe saw Sextons advancing deep into Germany, firing missions against bypass strongpoints and isolated German units. Operational records from this period document sustained high-tempo operations. Sextons fired, displaced, fired again day after day. Crew fatigue, vehicle maintenance, and ammunition resupply became critical factors. Royal Artillery maintenance echelons worked continuously, replacing tracks, servicing engines, and repairing battle damage. Ammunition convoys ran around the clock, keeping gun lines stocked. The system held because logistics anticipated the demand and production sustained the supply. By May 1945, when German forces surrendered, Sextons had fought from Normandy to the Elbe. The vehicle that entered service in Italy in 1943 ended the war deep in Germany, having participated in every major Commonwealth offensive in Northwest Europe. The gun's operational record validated the concept that had guided its design: tracked mobility, standard ammunition, and reliable automotive components created a weapon system adaptable to the demands of mechanized warfare. The final accounting took years. Production figures, compiled from factory records, showed Montreal Locomotive Works built 2,150 Sextons between 1943 and 1945. British and Canadian forces fielded the majority. A small number went to South African artillery units. The vehicle remained in service after the war, equipping Commonwealth artillery regiments through the 1950s and into the 1960s. Some saw combat in Korea. Others served in garrison roles across the Commonwealth. The Sexton's technical specifications appear modest alongside later self-propelled guns. 25 long tons, 25 miles per hour, 12-kilometer range. No revolutionary innovations in armor, firepower, or mobility. The gun succeeded because it matched a defined requirement without introducing logistical complexity. British planners wanted tracked mobility for the 25-pounder. Montreal Locomotive Works provided exactly that, using proven automotive components and standard gunnery equipment. The result was a vehicle that required no special supply chains, no retraining of ammunition handlers, and no separate maintenance doctrine. Comparative figures illuminate the vehicle's place in Allied artillery. Germany produced 676 Wesp self-propelled howitzers. The Soviet Union built thousands of Su-76s and Su-122s, but those were assault guns optimized for direct fire, not indirect fire field artillery. The United States produced over 4,000 M7 Priests. Among Western allies, only the M7 exceeded Sexton production numbers, and the M7 served primarily in American units after British forces transitioned to Sextons. The Sexton became the standard Commonwealth-tracked 25-pounder, a distinction reflecting both vehicle capability and ammunition logistics. Operational analysis from post-war studies noted the Sexton's contribution to artillery effectiveness. Mobile gun platforms reduced displacement times and increased survivability. The ability to fire and move quickly denied enemy counter-battery efforts. The concentration of fire support within close proximity to supported armor enabled responsive missions. These benefits, identified during wartime operations, validated the investment in self-propelled artillery and informed post-war equipment development. Individual crew accounts, collected in unit histories and memoirs, describe the vehicle in human terms. Crews appreciated the overhead armor protection from shell fragments and weather. They noted the cramped fighting compartment and limited ammunition stowage. They praised the gun's reliability and the availability of spare parts. Maintenance personnel valued the Sherman-derived components, which simplified field repair. Commanders appreciated the vehicle's tactical flexibility and the rapid response it enabled. The Sexton did not win battles through firepower or armor. It contributed to victories by enabling artillery to keep pace with armor and to deliver fires when and where commanders needed them. In that role, it succeeded as well as any weapon system of its era. The gun fired millions of rounds across 3 years of operations. It served in desert, hedgerow, forest, polder, and city. It crossed rivers on tactical bridges and advanced through mud, snow, and dust. It broke down, was repaired, and returned to service. Crews fired it until barrels wore out, then replaced barrels and kept firing. The operational story of the Sexton is the story of artillery mechanization during World War II, matching mobility to firepower, integrating logistics with tactics, and creating weapon systems that commanders could rely on across the spectrum of operations. The gun from Montreal served that purpose with quiet competence. Statistics from Northwest Europe operations compile slowly after the war. Researchers sift through unit war diaries, fire mission logs, and after-action reports. Some figures emerge clearly. British Commonwealth forces fired approximately 170 million rounds of 25-pounder ammunition during the war. Not all came from Sexton barrels. Towed 25-pounders fired the majority. But Sexton-equipped regiments contributed significantly to that total, particularly during the sustained operations from Normandy to Germany. Ammunition expenditure rates during major operations reach figures that strain comprehension. Operation Veritable, lasting 2 weeks in February 1945, consumed 2.5 million 25-pounder rounds. A single operation in a single sector expended more shells than some nations produced in entire years. The tonnage hauled forward, the labor required to distribute it, and the industrial capacity necessary to manufacture it all exceed the immediate understanding of those who did not experience the scale firsthand. Sexton batteries participated in that expenditure, firing thousands of rounds per battery during the operation. Battery availability rates provide another measure. Operational readiness percentages for Sexton units remained high throughout the campaign. Mechanical reliability, aided by Sherman-derived automotive components and experienced maintenance echelons, kept vehicles mission-capable. When breakdowns occurred, repair times remained short because spare parts flowed through the same supply system that supported Sherman tanks. The commonality that simplified logistics also simplified maintenance, contributing to the vehicle's sustained operational availability. Casualty figures for Sexton crews remain difficult to establish precisely. Open-topped vehicles exposed crews to overhead shell bursts and small arms fire, but the armor protected against fragments. Unit casualties reflected exposure during combat operations, but no comparative data suggests Sexton crews suffered disproportionately compared to other artillery roles. The vehicle provided protection where it mattered against the most common threats, while accepting vulnerability to less frequent dangers. The broader industrial context places Sexton production within Allied war economies. Montreal Locomotive Works, a single factory, produced 2,150 vehicles while also manufacturing locomotives and other military equipment. The output represented a fraction of total Allied armored vehicle production but filled a specific niche that other vehicles could not. The Priest provided mobile 25-pounder capability with ammunition incompatibility. Towed guns provided commonality without mobility. Sexton delivered both. Post-war assessments credit the vehicle with meeting its design requirements. British military analysts, evaluating equipment performance, noted the Sexton as a successful expedient. Canadian industrial contributions to Commonwealth forces included the Sexton among major achievements, alongside ram tank production, used for training and specialized variants, and other armored vehicles. The gun entered service at a critical moment, equipped formations preparing for the largest amphibious operation in history, and remained in service through the war's conclusion. That record speaks to both design adequacy and production competence. The final Sextons left service in the 1960s, replaced by newer self-propelled guns with enclosed turrets, longer-range weapons, and improved automotive performance. Some became monuments. Others went to museums. A few remain in private collections. The vehicles that survive carry no visible scars of their service. Factory cosmoline and post-war preservation obscured the wear of operations. But records remain. War diaries recording fire missions, maintenance logs documenting repairs, operational orders assigning missions. Those records, compiled and archived, tell the Sexton story more completely than the surviving vehicles can. The final operations occurred in scattered locations across northern Germany during late April and early May 1945. Sexton batteries fired missions against isolated German units, bypassed strong points, and targets of opportunity as Allied columns advanced. Some regiments fired their last combat rounds on the 4th of May, when German forces in northwest Europe surrendered. Other batteries, positioned farther east, continued missions until the 8th of May, the official end of hostilities in Europe. After the surrender, Sextons remained in service as occupation forces took control of defeated Germany. Artillery regiments, no longer firing combat missions, maintained vehicles and conducted training. The transition from combat to occupation required reorienting organizations built for offensive operations toward stability missions. Sextons, no longer displacing daily or firing sustained missions, sat in motor parks under maintenance. Crews performed services deferred during combat: engine overhauls, track replacement, thorough cleaning. The vehicles that had fought from Normandy to the Elbe now awaited disposition decisions from higher commands. British and Canadian military planners faced post-war force structure decisions. Demobilization reduced troop strengths, eliminating wartime formations. Equipment disposition included deciding which vehicles to retain, which to transfer, and which to scrap. Sextons remained in Commonwealth artillery inventories. The vehicle's automotive reliability and adequate firepower justified retention. Some units returned to Canada with their Sextons. Others remained in Europe or deployed to occupation duties in Germany and Austria. The gun's post-war service included Korea, where Commonwealth artillery regiments deployed with Sextons among their equipment. The 25-pounder remained the standard British Commonwealth field gun into the 1950s, and Sexton provided its tracked mobility. Korean operations tested the vehicle under different conditions than Northwest Europe: mountainous terrain, extreme cold, and positional warfare. Sexton batteries performed adequately, though newer American self-propelled guns offered greater range and protection. Through the 1950s, Sextons equipped Royal Artillery and Commonwealth regiments in garrisons worldwide. The vehicle aged as newer equipment entered service. Enclosed self-propelled guns, like the American M109 and British Abbott, offered cruise protection from weather and shell fragments, longer-range guns, and improved automotive performance. By the 1960s, Sextons were obsolete. Replacement proceeded gradually, with vehicles transferred to reserve units or disposed of as newer equipment arrived. The last Sextons left active service in 1972, when the final operators retired them in favor of modern self-propelled howitzers. The vehicle that entered service in 1943 had lasted nearly 30 years in Commonwealth arsenals, a longevity that reflected both the conservatism of peacetime militaries and the adequacy of the basic design. Few Second World War armored vehicles served as long. Today, Sextons survive in museums and private collections. The vehicles sit on static display, their fighting compartments opened for visitors, their guns elevated at angles they held while firing missions decades ago. Information placards describe specifications and service history. Photographs show the vehicles in wartime operations, gun crews loading rounds or commanders reading maps. The displays preserve the vehicle's physical form but cannot convey its operational context. The noise of firing, the recoil shaking the chassis, the radio calls from forward observers, the smell of propellant smoke and hot oil. The men who crewed Sextons are mostly gone now. Some recorded memoirs. Many did not. Unit histories preserve collective records but cannot capture individual experience. The gun's story survives in archives, museums, and the memories of a generation that grows smaller each year. Chapter 14. 588 words. The Sexton self-propelled gun represents a specific solution to a defined military problem. In 1942, British forces required tracked mobility for their standard field gun. Montreal Locomotive Works delivered a vehicle that met that requirement using proven components and simple engineering. The result served Commonwealth artillery from 1943 to the 1970s, an operational lifespan that validates the design's fundamental soundness. The gun's significance lies not in revolutionary innovation but in practical execution. Self-propelled artillery existed before the Sexton. The concept was not new. What Montreal Locomotive Works achieved was matching that concept to British logistics. By mounting the 25-pounder on a track chassis, engineers preserved ammunition commonality while adding mobility. The decision avoided the supply complications that plagued British use of American M7 Priests. Every Sexton round matched every towed 25-pounder round across the theater. That interchangeability simplified logistics at every level, from forward dumps to factory production schedules. Operational effectiveness stemmed from that logistical foundation. Sexton batteries could fire sustained missions because ammunition supply matched consumption. They could displace rapidly because their tracked mobility matched armored divisions. They could be maintained in the field because their automotive components matched Sherman tanks. The weapon system worked because every element gun, chassis, ammunition, maintenance, integrated into existing British practices without requiring separate support structures. The vehicle's combat record spans major Commonwealth operations in Italy and Northwest Europe. Sextons fired during the breakout from Normandy, supported river crossings at the Seine and Rhine, participated in urban fighting and open country pursuit, and delivered fires in every type of terrain from beaches to forests. The gun performed its mission, indirect fire support for advancing armor and infantry, across 3 years of sustained operations. That record demonstrates not individual brilliance but reliable competence, a quality often more valuable than technical superiority. Post-war assessments note the Sexton among successful wartime equipment developments. Military analysts credit the vehicle with meeting stated requirements and providing commanders with a tool they could rely on. The gun never achieved the prominence of tanks or aircraft in popular histories, but artillery officers knew its value. Forward observers counted on Sexton batteries to deliver fires when called. Supported infantry trusted that artillery support would be available when needed. Maintenance personnel appreciated the vehicle's reliability and ease of repair. Those practical judgments, formed during operations, matter more than technical specifications. The broader lesson concerns matching weapons to requirements. The Sexton succeeded because its designers understood the problem they were solving. British forces needed mobile 25-pounders, not a new gun system. Montreal Locomotive Works provided mobile 25-pounders using available chassis and components. The solution avoided complexity and worked within existing logistics. That approach, solving defined problems with adequate tools rather than pursuing technical excellence for its own sake, characterized successful equipment development throughout the war. The Sexton story also reflects industrial contributions from Commonwealth nations. Canadian factories produced equipment critical to British forces while developing their own military industries. Montreal Locomotive Works output included not only Sextons but also ram tanks, used for training and specialized variants, Valentine tanks, and other armored vehicles. The production represented Canada's integration into Commonwealth war efforts and demonstrated the industrial capacity necessary to sustain mechanized warfare. Today, the Sexton remains a footnote in histories dominated by tanks and aircraft. Yet the vehicle participated in every major Commonwealth operation in Northwest Europe. It fired millions of rounds in support of advancing armies. It served for 30 years, longer than most contemporary armored vehicles. It met its design requirements and performed its mission across varied terrain and conditions. That record, modest but solid, marks the Sexton as a successful weapon system by the measures that matter: reliability, availability, and contribution to operational success. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.